The conclusion we've come to from that is that there's a significant spherical aberration appears to be present in the optics,
and that we should be able to fix it in our insurance program.
One of the problems with Hubble was we predicted success before it was launched. And it's easy to do. They're so excited about what we're going to discover and see, that's all they talk about. They don't talk about the risks. Everybody's telling us what we can't do. We got to find out what we can do.
And we have liftoff. Liftoff of the Space Shuttle Endeavour on an ambitious mission to service the Hubble Space Telescope.
There were a lot of people who were ashamed, who did not want to work on Hubble. People were generally not real proud to be working at NASA at that stage. People were taking NASA bumper stickers off their cars.
We got a very clear and distinct characteristic, a textbook characteristic, if you will, of an optical system which had a significant amount of spherical aberration.
I wanted to say, how can I help? That was my only reaction. You know, people measure you on how you respond to it, not necessarily the problem. And history, many times, is centered around the response, not just the problem. And so I wanted to be part of the solution, and I wanted to help. I just generally wanted to help. Servicing Mission 1, people always fail to recognize, was always planned. It was planned to be able to replace the wide field planetary camera and potentially repair or do whatever engineering maintenance was needed. When the flawed mirror was found, the objectives became, I need to fix the optics, correct the optics. The second problem was a jitter of the solar rays. The thermal design and the structural design of the solar ray deployment mechanisms would bind up. And so in the cold, they would bind up, and as you came into the light, the heat would hit it, warm up, release the tension, and there'd be the solar rays being large, floppy structures would flap, and until that settled down, it was hard to point the telescope accurately and hold it steady. You were losing 5 or 10 minutes of the observation time. One of the things that we did as a team, the management team, we sat down and set out a strategy, because the first thing we had to do was also convince our stakeholders, particularly the scientific community, and then the Congress who was funding us, that we actually had a plan, could fix it, could do it on a schedule that was credible, and do it within the budget that we predicted for it. And the first goal was we were going to fix Hubble. The second goal was very important to the scientific community. We weren't going to take any money from the next generation instrument development to solve the problem up front. We want to allow that to proceed. And then the third thing was we were going to ensure we did all the maintenance to extend the life that we would have normally done. We set those out, very clear objectives, and we invited the scientific community to review us and measure us on every decision we made. So that was an important part to start to build confidence that we had a plan in simple enough terms that everybody could look at it and judge our actions based on that. The public really supports a risk. They support risk takers, and they can even accept failure and allow you to try it again. But if you surprise them and tell them, I'm going to be successful, then have a failure, and then say, oh yeah, this was risky, you lose your credibility, they lose confidence in you, and they're also not really interested in being part of your team. So my job was to make sure we had a good team, they had the right resources, and run interference for them, being able to motivate, being able to read and trust people and rely on them. Give them the freedom to do things and have faith in them. Get rid of outside distractions as much as you can. I mean, we were going to do everything we could to ensure success. We quickly were learning that we needed more than one EVA day, which was all we were allotted when it started. They hadn't named the crew. We were now going into June or July of 1991. No crew named. One EVA day. This isn't your regular mission. They tried to name the crew no sooner than 1 year before the mission. The reason they never named the crew early is because people get sick, people have problems, and by getting a crew name too early and starting to training, they would like to stay as close as possible to the launch date so to minimize the retraining and change out of crews. We tried to make the case. Then we began getting independent reviews. The administrator, Dan Golden, believed that it was very important, and he was right, that we assure we've done everything humanly possible in case it does fail, that nobody can point at us and say we took anything lightly. The importance of training and what we were doing, how long it was going to take, and we're 22 months before launch and made a plea to name the crew. So at the end of the 2-day review we got the crew named. We messed around with that for probably 6 to 9 months trying to get the crew named. So that was one challenge. The second one was the number of EVA days, and we used another review to point out that this is what needed to be done for, at that point we were still talking about mission success, and there's no way we're going to do it in 1 day and 2 days. And so we used the reviews to get an additional day, and we finally got to the 5 days. But those, to me, were the bigger challenges, was to get everybody lined up on the same page, believing what was needed, and then committed to executing what was needed for the success of the mission. And during that mission, I slept maybe two hours a night, maybe. We'd get off and we'd go have breakfast, and then I'd go back to the hotel, and then I'd always kind of hang awake until noon and see the briefing just to see what was going on, and then go back to sleep and maybe sleep for an hour or two. And it was hard. You were on adrenaline. And I don't think I slept the whole week very much. I had full expectation that we did everything was needed, that if nothing mechanically went wrong, in other words, or nothing operationally went wrong, that the outcome was going to be a clear image. Right out of the get-go, there were amazing imagery coming back. It wasn't a surprise to me. I had no fear that we didn't engineer something that was going to be a 99.9 chance. So I don't think discoveries for Hubble or most scientific observatories lead to answers. They lead the next set of questions, especially when there are surprises, because suddenly you challenges the fundamental theory. I think the imagery from Hubble to this day still is something people look at and talk about, and anybody from guy sitting next to you in the bar to somebody sitting on an airplane. I used to lay on my back on the grass in the local greens in New York City, look up at the sky and wonder what's out there. I mean, not a clue. I just look at. I mean, at that time I couldn't spell galaxy. I knew nothing, but I used to wonder what was out there. And that sense of wonder, you look at the Hubble imagery and it just magnifies it a million times. The wonder what all we don't know. We're just a little grain of sand, and not even in the universe. It may be opening a lot of young people's minds and having them pursue careers in areas because they now become curious.
Hopefully history will remember not us by the problem we had with Hubble, but how we faced up to the challenge and did something about it. And I think in reality we have, and in spades will be remembered as stepping up to the challenge and knocking it down and turning it around into a victory. And I thank the entire team for their support in doing this, and many people contributed to this. Thank you.